So today, what you're looking at here is us jumping in to our episode on momentum. This, of course, is a Newton cradle. It's also called an executive ball kicker, and this device illustrates the conservation of momentum, which you will learn all about as we go through our series of videos. Today's lesson is an introduction to momentum. We're going to define what momentum is, look at the formal definition for it, and also do some calculations on the momenta of moving objects. So I would like you to think of momentum as mass in motion. It is an indication of how hard it is to stop an object. So I've got two objects here, a car belting down this piece of country road, and I've got a tennis ball example here being hit by a tennis player. Which of these two objects, the car or the tennis ball, do you think has the greater amount of momentum? The amount of motion, do you think that depends on the mass of that object and maybe how fast it is going? You would be absolutely right. We know and we can see that this car has a much greater mass, and it's got quite a great mass compared to the tennis ball. It has quite a high velocity. It's quite moving quite fast in a certain direction, so its velocity is high. And we say its mass in motion, or its amount of motion, is quite high. And we therefore say its momentum is quite high. The symbol we denoted momentum is little p. Compared to the tennis ball with a much smaller mass and a much smaller velocity, this tennis ball would be much easier to stop, and therefore it has a lower momentum than that of the car. So now, thinking of the formal definition of momentum, this is what you should write according to the CAP syllabus. The formal definition for momentum is the product of the mass and velocity of an object. I would like you to just have a look at two objects, a bowling ball and a softball, both moving at the same velocity. Which one would you think will have the greater momentum? Obviously the bowling ball, because it has a much greater mass than the softball, and it would be much more difficult to stop. That indication of how hard an object is to stop is its momentum. It is the product of both the mass and the velocity of an object multiplied together, and therefore this bowling ball has a much greater momentum, denoted the little symbol P, much greater momentum than the softball. If we look at two objects with the same mass, but moving at different velocities, the object moving at a smaller velocity will have a smaller momentum than the object moving faster, which will have a higher momentum. We can therefore now say that momentum is affected by two factors. Momentum is directly affected by mass. That means if the mass of an object increases, its momentum will increase. If the object moves faster, it will also be more difficult to stop, and therefore its momentum, its amount of motion, will be greater. So momentum is directly proportional to the velocity of an object. If we look at two variables that affect the same physical quantity, then we always multiply their effect together. And so we get that momentum is directly proportional to mass. It's also directly proportional to velocity. So the combined effect of mass and velocity on momentum is the product of them two. So the formula for momentum is this: P is equal to M times V. Take note of the units. Mass should always be in kilograms. Velocity should always be in meters per second. And that now obviously gives the unit for momentum as kilogram meter per second, not kilogram per meter per second, because we are taking kilograms and we multiply it with meters per second. So the answer is just of that unit, kilogram meter per second. Please take note that is the unit for momentum. If we look at these two graphs, graph 1 and 2, we can see that momentum is directly proportional to velocity, just as momentum is also directly proportional to mass. That means as the velocity increases, the momentum of an object will also increase in direct proportion. And as the mass increase of an object, the momentum will also increase in proportion to the mass. We therefore get these straight line graphs showing this relationship between momentum, velocity, and momentum and mass respectively. We can therefore say that the factors that affect momentum are both speed and mass. An object with zero speed will have zero momentum if it's not moving. An object with zero mass will obviously not exist. That wouldn't be an object, but it would mean it has zero momentum. An interesting example of particles with no mass are actually photons, the smallest particles of light. But they have such a great velocity that they still have momentum. All right, so we can also see that if you have two objects with the same mass but different velocities, the one moving fastest will have the greater momentum. If two objects have the same velocity but they have different masses, the one with the greatest mass will have the greater momentum. So these are the factors that affect momentum. Just to recap, the definition again for momentum is the product of mass and velocity of an object. That yields the formula P is M times V, momentum with the unit kilogram meter per second. Take note that velocity is a vector quantity and hence also momentum is a vector quantity. That means it needs both magnitude and direction to be stated when you actually calculate the answer for momentum. That means that you can get positive momenta and negative momenta values for an object. You always have to change a negative answer to a positive answer, stating the opposite direction with that positive answer. Let us look at a few examples of calculations. This bus has a mass of 5,000 kilograms and it's moving due west at 10 meters per second. Find the momentum of the bus. So we know that we are given velocity, we are given the mass of the bus and we are given the velocity of the bus. How would we be able to work out the momentum? Well, we've got the formula P is mass times velocity. The mass we substitute and we need to make sure that it's in kilograms. Indeed, it is correct. 5,000 kilograms multiplied by 10 meters per second. This is also the correct unit, meter per second for velocity. And that yields 50,000 kilogram meter per second. Because it's a vector, you have to state the direction as due west. Take note again, momentum is a vector, and so you need to state the direction. Here's an example. A car with a mass of 2,000 kilograms travel at a velocity of 32 meters per second. This is my mass, this is the velocity. What is the momentum of this car? Little p is your question mark. I want you to just pause the video and quickly do your calculation. So this is what you should have gotten. Momentum is mass times velocity. That's your first mark. Substituting the mass and the velocity in as kilogram and meter per second given to you will give you another mark. And the answer with the correct unit, 64,000 kilogram meter per second, in the original direction, let's call this forward, will give you all of your marks. Here's another example. An 8 kilogram bowling ball is rolling straight towards you. Its momentum is 16 kilogram meter per second. How fast is it traveling? Quickly pause the video and calculate the answer, step by step, please. Right, welcome back. This is what you should have done. The mass is given to you in the correct unit and you're given momentum. You have to work out the velocity of this traveling bowling ball. So you always start with your general formula, P is m times v. You substitute in what you have, given that you have them in the correct units and don't have to convert. The mass is in the correct unit as kilograms, and it's 8 kilograms, and you multiply that with the velocity. You want to get the velocity as the subject of the formula because that is what you need to calculate. How fast is it traveling? So you need to calculate v. We have to therefore divide away with 8 to the other side, and that gives us 2 meters per second towards the observer, because that is the direction given. Remember, velocity is a vector, and so you need to state a direction as well. I would like you now to please pause the video here and do these practice questions. The answers are given to you. Make sure that you do this step by step. First, the general formula, then substituting the values in, and lastly, give the answer with the correct unit in kilogram meter per second and with the direction.